Today we will discuss about the sets. This is a chapter of mathematics, and so we will start from the introduction. The concept of set serve as a fundamental part of the present day mathematics. So, what do you mean by fundamental part of mathematics? Fundamental mean important, important, important part of mathematics. So, today this concept is being used in almost every branch of mathematics. So, this is an important topic to understand each and everybody. Sets are used to define the concept of relation and functions. The study of the set, study of the geometry, sequences, probability, etc. So, for the study of relation, function, geometry, sequences, probability, the knowledge of set is required. So, required knowledge of the set. Now, so let's understand about that, and the theory of the set was developed by the German mathematician George Cantor. And the objective of this chapter, we will discuss some basic definitions and operation involving sets. So, in this chapter, the first topic after introduction is sets and their representations. In everyday life, we often speak the collections of objects of a particular kind, such as a pack of cards, a crowd of the people, a cricket team, etc. So, the word collection is important here. Collections of objects. The collections of object, we often can say that the set, but according to the rule and regulation about the set theory. In the mathematics also we come across a collection. For example, of natural number, it means the collections of natural number. Collections of natural number mean 1, 2, 3, 4, 5, dot dot. So this is a collection of natural number. The collection of points, the collection of prime number. So the collection of prime number is 2, 3, 5, 7, dot dot. So this is also a collection of prime number, etc. etc. More specifically, we examine the following collections: odd natural number less than 10. So these all are the odd natural number less than 10. So this is also a collection. Collection of odd natural number which are less than 10. This is a collection of prime number, and this is also a collection of natural number. The The rivers of India. This is a collection also. If we like as a river of Ganga and Yamuna, so we can also make like that a collection. And after that, the vowels in the English alphabet, namely A, E, I, O, U. So these are also a collection. So various kinds of a triangles. Various kinds of a triangle mean the different type of a triangle, collections of different types of triangle, like as a equilateral triangle, scalene triangle, isosceles triangle, right angle triangle. So this is also a collection of a triangles. Now the fifth point is a prime factor of 210, namely 2, 3, 5 and 7. So these prime factor of 210, if we find all the prime factor of this number like that, so we will find all these factors. So these are also the collections. And now the next point, the solution of the equation this. When we split this number, so we will get the solution. Solution of this quadratic equation. If we will split this equation by the middle term factorization, like as x square minus 3x minus 2x plus 6. So, and we will solve this equation. So we will find the roots and find the value of x. So these two value also make a collection of this quadratic equation. Okay, so we note that each of above example is a well-defined collections of object. So all these collection, like collection of a natural number, collection of a prime number, collections of odd natural number less than 10, collections of vowels, collections of factor of number 210, and collections of the quadratic equation roots 2 and 3. So all these collections are well defined. Okay, so these collections are well defined. So what do you mean by well defined collections? Let's understand the sense that we can identify, sense that we can definitely decide it whether a given particular object belongs to a given collections or not. So for example, we can say that the river Nile doesn't belong to the collections of rivers of India. On the other hand, the river Ganga does belongs to these collections. Okay, so we will be given below the few more examples of the set use, particularly in mathematics, ways this capital N, highlighted capital N, represent all the time the set of the natural number, and same highlighted Z and bold Z always represent the set of all integers. So all these capital letter alphabet and symbols represent the collections of different types of set, like as a R is the set of a real number Z, Z with positive sign represent the set of the positive integer, Q with positive sign represent the set of positive rational number. You know, any number we can write in the form of P by Q, and Q never equal to 0, so number will be a rational number, like as 1 by 2, 3 by 5, like that. These number are a rational number. So Q plus represent these type of collections of set of a rational number, and R plus the set of the positive real number. The symbol of the special set A given above will the reference of throughout this text. And again the collection of five most renowned mathematician, renowned means famous, mathematician of the words is not well defined. Because why renowned mathematician are not well defined? Because the criteria for determining a mathematician as most renowned may vary from person to person. So thus it is not a well defined collections. So we shall say that a set is a well-defined collection of objects. That is a definition of a set. Definition of set. Definition of set means well-defined collection. Well-defined means which will we can define. So this defined type of collections of object always consider the set. If we defined any particular collections of object or any people in this world defined collections of object, so that type of collections always consider a set. The following point may be noted. An objects, elements and members of a set are synonymous terms. What do you mean by synonymous? Synonymous mean same things. So suppose we have a collections of set of vowels. This is a collection of set of vowels. So this is a element of this set. This is also a element of this set. I is also element of this set. O is also element of this set. U is also element of this set. In place of element, we can also say that members. Or we can also say that objects. So that line tells us this. And the set are, point number 2, set are usually denoted by capital letter. Suppose if you want to represent this set, so you can easily represent like that: A is equal to this or E is equal to this, only with their capital letter. Okay, so you can choose any capital letter for representation of any set. And the point number 3, the elements of the set are represented by the small letter. So suppose any set of 2, 4, 6, 8, 10. This is a set of even number less than 12. So this 2 we can represent like A with a small letter. This 4 we also can represent A. This 6 also we can represent with a small letter. But this whole set only represented by the capital letter. So these points are very important to understand the set, how to write the set, and element, object and member are the part of the set when we represent. So these are the requirement points or requirement things to understand a set. If A is an element of a set A, we say that A belongs to A. Suppose this is a set, so this is A, and this whole set is capital A. So this A is an element of this set. A small letter A is an element of this capital letter A set. So we can write like that: B belongs to set A. The Greek symbols this symbol we call epsilon, to use to denote the phrase belongs to. This epsilon sign called belongs to. So thus we write A belongs to A, small a. A belongs to A. It means A is an element of set A. If B is not an element of a set A, we write like that: B not belongs to A, and read as B does not belong to A. So guys, these small things are very important to understand set and how to represent set when we solve the problems. Thus in the set, suppose V, because V is in a capital letter, so it represents a whole set. V of a vowel in the English alphabet. So A belongs to V, but B doesn't belong to V. In the set P of a prime factor of 30, so 3 belongs to P, but 15 not belongs to P. Because of that, if you go to factorize 30, so the set of prime factor, this will be, we can write like that: 2, 3 and 5. So 3 we can write like that: 3 belongs P, and 2 also belongs P, and 5 will also belong P, but 15 not belong P. Okay, so this is a representation of belongs. So which element belongs in the set and which element is not belong in the set, you can represent like that. Okay, so there are two methods to represent a set. First method is a roster or tabular form, and second method is a set builder form. So these two methods to represent a set. Okay, so I think you all understand the introduction of the set and what is the set and how to write a set. Okay, so we will discuss rest of the part in other video. Thank you.